Okay. Last bench. Please concentrate here. So, whichever part I have explained, you can see that in this diagrams. Okay. So, this diagram will indicate the sink marks. Okay. Here, this is the top surface or top layer. This kind of marks will be formed as material is not available there. Okay. Then this is the warpage. Okay. This is your initial diagram. Then after cooling, as this portion is thick, no problem will be there at this portion. Means it will cool on time. Okay, or it will cool rapidly as per we desire. But in this thick section, what will happen as its corners, the surface layers will cool rapidly, or initially they will solidify and they will pull. They will try to attract the material from the other areas. As solidification will start at the corners. From end corners, it will go to the center. Okay, are you getting this? And due to that, what will happen? This kind of bending will happen there. This end portion will solidify initially, and this bending will get created. Okay, this kind of defects will be there when we are not using the uniform wall thickness, or when there is non-uniform wall thickness is there, then due to that thick sections, these kind of defects are possible. Then next diagram or the next slide, you can see here how we are modifying the designs. Okay, here these are the initial designs or incorrect designs, you can say that incorrect designs we are modifying. If design is correct, then there is no need to modify it. Or don't feel like that whichever design is given at initial stage is incorrect and modified. It will be not that like that. If there is a need, then only you have to modify it. Okay, and which points you have to consider? As far as possible, you have to go for minimum wall thickness, and it should be uniform throughout. Okay, so these are some examples, 3 examples, and how they are modified. In this way, they have modified it. Okay, and while modifying it, you have to take into consideration only 2 points: minimum wall thickness and uniform wall thickness. Okay, here this portion, if you find out this portion, it is a very thick portion. Okay, then this is converted into thin sections, or we have provided minimum wall thickness and we made it uniform also. Okay, in this way. Okay, how we means how this is obtained, or what we are doing, whichever material is in this portion, we have eliminated it, just taking out that material. Okay, whichever thick portion is there, just we have removed this material, this much amount of the material. Okay, for doing this, we are using the coring. One metal section will be inserted there, and we will eliminate, or we will avoid the plastic material to enter in that space. Okay, how it is provided, I will show you that diagram also. So whichever thick portions are there, we are modifying them, as that thick portions will result in the defects like warping or sink marks or voids may be there at the center portion. Then second design, please consider this design here, this diagram. Okay, here also thick portion is there. Here at this end corner, both corners are having thick sections. Then we are modifying it by providing uniform wall thickness. And wherever we find that the corners are there, sharp corners at these points, sharp corners are there, because at the sharp corners stresses may be there. Okay, we are avoiding it by providing, or we are eliminating it by providing the corners, or by giving the radius. Corners are nothing but we will provide a radius like this. Okay, like this shape we are providing the corner or radius. We are going to discuss it in brief, how that radius should be provided related to the dimensions depending on the structure. Okay. Just try to remember this. Here more stresses are there. To avoid that, we are providing the radius. Okay. Here also, this is the thick portion. Okay. Here in this diagram, you can see very thick portion is there. What is our aim? To get the minimum and uniform wall thickness. Then how it is obtained? Like this. We have eliminated the material in this section by providing the coring. Okay, metal coring will be provided. Okay, so in this way designs are modified. Then in the last diagram also here, whichever change in the thickness we are providing, okay, change in the thickness, don't provide the sudden change. Okay, don't provide the sudden change. Here you can see in this diagram, sudden change is there in the thickness. You have to avoid it. That change in the thickness should be gradual. When gradual change is there, you can say that stresses will be less. Gradually changing thickness will be there, and stresses will be less. Okay, so if sudden change in the thickness is there, you have to eliminate it. You can go for any one design. Okay, gradual change here by providing the curve. Okay, or you can see this type of curve, or you can provide taper also. Okay, instead of going for sudden change in the thickness, go for the gradual change. Okay, so in this way you have to modify the design, and you should get the you should provide the minimum and uniform wall thickness for that component. Okay. Okay, this is the part. Already I have explained this. The thick portion is there. You have to go for minimum wall thickness. Some part is repeated. Okay, here some designs are there. Okay, this is the design, initial design, and in the bottom side you will get the modified design. Thick portions, we are eliminating it by providing the thin portions like this. Okay, when thick portions are there, warpage may be there, or you can see here sink marks may be there. So to avoid this, we are providing uniform wall thickness. Okay, then these sharp corners are nothing but your stress points. These stress points we are eliminating. Okay, here by providing the radius. Getting this? In this way, design is modified. Okay, already I have explained this. Okay, whichever sudden change is there, instead of providing the sudden change, go for the gradual change in the wall thickness. Okay. So here also, whenever thick portions are there, make the radius, try to make the thickness of that wall uniform throughout. Here if you find that at this end corners, more thickness is there. So modify it, make it uniform throughout. If possible, make it uniform throughout. If it is not possible to make the wall thickness uniform throughout, then change should be gradual. And wherever sharp corners are there, eliminate that sharp corners by providing the radius or corners. Okay. Okay, whenever very heavy sections are there, heavy sections, solid sections, then you have to modify it like this. Go for the, instead of using heavy sections, you can go for the hollow sections. Okay, means hollow sections means this internal material will be eliminated. Okay, so these are some diagrams where means we are providing the uniform thicknesses. Okay, instead of using this thick portion, go for this modified design like this. Okay. These are the modifications made. These diagrams are there. Just try to observe that we are going for uniform and minimum wall thickness as far as possible. Try to get the minimum wall thickness and uniform thickness. Okay, uniform wall thickness should be there. Okay. So I have summarized here that minimum wall thickness part. Basic rule is, as far as possible, wall thickness should be kept less and it should be uniform throughout. Large wall thickness for the solid parts will affect the economy of the mass production. Already I have explained this. Then thick sections are poor conductors of heat and they shrinks more than the thin sections. That sink marks will be more. Okay. And wall thickness is 0.1 to 5 mm. Whether I have written 0.5. So please modify it 0.1 to 5 mm. Okay. Please modify it. I think I have written 0.5 to 5. Please modify it 0.1 to 5 millimeter. Okay. And parts should be thin for faster cooling, lower weight, and higher productivity. Already all these points I have explained. This is just the summary of whichever part I have explained. This is just the summary. And you can write this summary and write that reasons with the by writing some formulas. The formulas you can write that cooling time is directly proportional. Okay, if the whole formula is not there, you can just directly write it is directly proportional or it depends on like this. Cooling time depends on wall thickness. You can explain according to that. Okay. So this is the concept of minimum wall thickness. Okay. This is very important concept. Try to understand it. It will play very important role in the plastic part design. Okay. So after this, we will move towards the next point, that is tolerances in plastic part and allowances in the plastic part. Okay. I have added this slide here. What's time? Okay, I will take this in the next session. Okay, tolerances and allowances will complete in one session only. Okay, I will complete this part, coring, with a very short point, and already I have explained it. What is the coring? Okay, here you can go through some points. Heavy sections to be cored, whichever heavy sections are there, need to be covered to provide uniform wall thickness to reduce the sink marks, some blowholes, and thermal stresses. So here, just go through the points. I will show you the diagram. Coring at right angles to the direction of the mold opening requires some cam and hydraulic action, which increases the mold cost. Means how to operate that coring, how to provide that coring. Then whichever movable or loose pieces of cores are there, it will take some cost. Okay. Then what is the meaning of coring? It is highlighted in this green color. Coring refers to elimination of the plastic material from that thick section. Already I have told you, while in the modification of that design, wherever thick portions are there, we are eliminating that extra material from the heavy sections. That process is termed as the coring. And how it is obtained? Generally, we are providing the metal coring. Okay, I think I have mentioned it that point also here. To prevent that, the steel is added to the mold, which results in the pocket or the opening in that part. If I am providing that metal or that steel part, then opening will be there. If Okay, opening or that pocket will get created. Okay, I will show you the diagram. Okay, here this is your thick portion. Okay, here everywhere you will feel that thickness is very on the higher side or more thick parts are there. Then how it is modified? In this way it is modified. This material, extra material is eliminated. Okay. This extra material is eliminated, and how it is eliminated? By providing the metal in that part. That particular part we will provide the metal. It is termed as the core. Means just we are eliminating that material. From that, here you can find that this extra material is present. Okay, due to this material, that part is becoming very thick. Okay, so different defects may be there. That sink marks may be there. Some blowholes or voids may be there, or some thermal stresses may be there. So to avoid this, we are going for uniform wall thickness. Okay, here throughout we are getting the uniform wall thickness. That material is removed. That extra material is removed by providing the metal part there. Okay, and that metal portion, whichever extra portion we are providing for removing that plastic material, extra plastic material, it is termed as the coring. Got it? So this is the design guidelines for the providing the coring in the plastic part. Okay. So in this today's session, we have completed the concept of minimum wall thickness and design guidelines for the coring. Why we are providing the coring and how it is provided, and generally we are using the metal corings. Okay. So I think we will stop here. Time is about to over. Okay, due to some electricity issues, I think I have conducted only 30 or 40 minute session. Okay. So in the next session, we will start the or we will discuss the tolerances and allowances in the plastic part. So one notice is there. I think I have not announced through online mode. Okay, those who have applied for the Earn and Learn scheme, their interviews are scheduled today. Okay, in the International Conference Hall at 5:30 p.m. So please attend it or present at that particular location or venue on time. Okay. So please take note of this and act accordingly. And if you are having any queries in today's session, you can ask me. Those who are attending through online mode, you can put that query in the chat box. This is the query. You can see on the screen. So if you are not having any query, you can put your roll number in the chat box and you can leave the session.